Let's take this fragment of code and see if we can really compile it and be able to run it and see what happens if we do. I'll just copy and paste this into my sample program. Just format it a little bit for our use, save it, see if it builds fine, and you see that it gets built just fine. If I try running it by pressing F5 or going to debug and start debugging, what I get is this message that there is an exception at this specific location of my program, and it's making an illegal attempt to access location F8, which is a hexadecimal value of 248. So of course this was just a random number, and I just trying to access a memory which may not belong to me, or I don't have privilege to access that memory, be able to write into it. So obviously this is an expected result. However, still the program was compiled, was loaded into memory, and was attempted to execute. So oftentimes, if you know exactly what you're doing at the low level when you're programming components of an operating system, then locations like this could make sense, and they could represent input-output ports of certain devices and so forth and so forth. But anyway, this code runs, and it's pretty close to the way it was originally written in 1970s when the first Unix system was put together on PDP-7. At the end of debugging session, I typically just go to debug menu and say stop debugging, because I have seen exactly what has been happening in this code, so now I know what it does. And as we discussed, if we want to access various types of data in computer memory, if we want to use this original example, we would have to figure out what is the location of a specific object in memory and provide its type. And notice that the syntax requires use of parentheses to override the compiler precedence rules when we specify our type of our location. So the asterisk right here in our syntax examples indicates the data type in memory, and this syntax could not be applied or in a different manner without an asterisk, because that syntax would just not accomplish anything, because this already has a different meaning as a typecast operator. So anyway, we must use an asterisk to tell the compiler that location that we're trying to use is actually an address of this type of object in memory. So there's another demonstration of the code, and we say that each time our program executes, it can be loaded into a different physical memory. However, we want to apply addresses from the beginning of memory. The memory variable represents beginning of memory at location 0. So hello is stored in memory as a sequence of bytes. To keep track of that sequence of bytes, compiler uses memory location of the first byte. We already discussed these types of string literals, and you already know that compiler would return the address of the first character as a result of storing this string of characters in computer memory. But what I'd like to use here is just brute force this location to reinterpret it as an integer and store this location as an integer in this presentation. So once I have this done, I can print this location. And so I can see some decimal number that is unique address of the first character of a string hello. So let's try this example in our code. I'll modify our program, just copy and paste this, and of course I need to say include iOS 3, and apparently we're using cout of the standard library namespace, so we can use just cout without std prefix. Okay, so let's try this example and just see what it does. We'll print this, build the code and print the location. Just adjust everything on my screen, make everything visible. And you can see that this is really printing this strange looking decimal number, but really this is a physical address of the first character that is being stored in our memory. Now there is another portion of this demonstration which is just a loop that asks us to provide new location. So we can see that the location of character H is whatever we're being prompted to. So now we can use this as a playground to try nearby locations and see what we can print from these places. So this time we use our memory, which is simply set to 0, but then we combine it with the location of the first character right here. And of course syntax requires us to explicitly provide information to the compiler that this is location of a character, and then we should be able to see what kind of character is there. So let's add this loop to our demonstration. Is just play with it and just see and explore characters in memory by specifying their direct location. I'm adding this loop to the program just as we have in this handout. I'm building the code. Oh, it tells me that sin is undefined. And this is of course because I have to add another using directive right here to say that I also am using both output and input standard output streams, input and output streams. So let's try this again. And I will try to run it. So as you can see that right now I'm printing that the location of my first character in the string hello is stored at this address. So then I can copy and paste it right here, and this will be our new location. We're going to read this location right here, and then we'll try to go to that location and print the character out of that memory. So I'm just copying and pasting the same number, and you can see that it tells me that this is character H. If I repeat this again and move to the next character, which has to have another address in memory, and hit enter, you can see that it gives me, it prints the next character in memory, which is character E. So this is a little gameplay with directly entering memory addresses and being able to access individual characters, specifically going to their physical location and asking program to print content of this location. Of course, if I add more numbers, like go to 66 and then 7 and then 8, you can see that I'm just sequentially printing these characters. If I enter some kind of strange location which just looks ugly like this, most likely I don't have any authority to access there, but I tried. You can see that the program actually exited with another exception. And if I run this in debug mode, definitely I will be able to find out that this was another memory access violation. So I was a little careful using narrow range of my characters right here, but if I try something outside of this range, going to some other place, of course this terminates the execution.